All right, so I decided to do one more trig substitution just for fun. Not that they're fun. So, this one, I already erased the things, but this one is going to involve sine. So remember the forms, a squared minus x squared plus a squared, and then x squared minus a squared. This is the first type. So you're going to take the square root of 36, which is 6. This time you're going to use sine. So the derivative is going to be cosine. D theta, which I forget often myself. Now I'm going to make my substitution, right? That's the whole point of making a trig substitution. You're going to put the 6 cosine theta d theta up at the top. That's why I put the dx there for you, to make it convenient. I'm going to square this. That's going to give me 36 sine squared theta. And then I also have to plug that into the radical. So, and again, I'm just going to save myself one step. I'm still going to do this on the side. All right, so as I always told you to do, take the radical, put it over here, do the simplification. Even though it doesn't take a lot of work, I have to see this. I have to see this simplification. Factor out the 36. That leaves me with a 1 here and a sine squared there. Remember, it's theta. I write it all the way out. 36 stays. My 36 looks horrible. 1 minus sine squared is cosine squared. 36 comes out. Square root of 36 is 6. Square root of cosine squared. Now that one looks just too awful for me to leave there. So it's cosine squared. Squared is squared. You get the original guy back. So I'm going to replace my radical with that. And you'll see it actually is pretty convenient here. So that was my dx. dx. This was x squared. That's going to stay there. And then I simplified my radical on the side, and I got 6 cosine theta. Now I'm going to cross out the 6's. Yay! Stuff crosses out. Cosines cross out. Usually a lot of stuff crosses out. I gotta be careful. Cross out the whole thing. So everything is gone except for, now be very careful here. I have 1 over 36. I don't like that in there, so I'm just going to move it out in the front. I have 1 d theta over, right? 1. There's a 1 there. When these cross out, put the 1. 1 over sine squared. So you don't mess this up. Because if you mess this up, if you would put sine squared there, you completely screwed yourself over. You got to be very careful when you do the crossing out. Make sure you're neat, organized. Now, I'm going to replace that. I'm going to keep my 1 over 36 out in the front. I'm going to use my reciprocal guy, right, which is cosecant squared. Why am I doing that? Because I know that that is the derivative of somebody. That's the whole point. You got to play little games when you get here. This is why we did trig integrals before trig substitution. You have to know how to handle all these integrals when you see them with trig functions. That's why, I mean, we literally spent like 3 classes working on trig integrals with sines and cosines, tangents and secants, so that when we encounter things like this, we know what to do. But this, you could do this one even if you didn't know the trig integrals, right? You know that the derivative of cotangent is negative cos squared. So I'm going to be able to integrate that. But again, I need room because I have to draw my triangle. So I'm going to erase all this. Okay, so now that I've erased everything, I'm ready to do the antiderivative, which I will. So I know now, remember, the derivative of cotan is negative cos squared. So I'm going to have negative 1 over 36 cotan theta plus c. Yay. And I mean, look, the problem is done. You're done. You've integrated it. You started with something that you could not integrate. You replaced it with trig functions, got rid of the radical, and you integrated it. But now I have to put it back the way that it was. This most certainly does not look like this. So I'm going to have to draw a triangle. So I'm going to take my original substitution that I made, and I am going to solve it for sine. I'm going to divide both sides by 6. I like the way it looks this way, so I'm going to write it this way. Right? Just divide both sides by 6. No problem. Right? So my original trig guy, my original substitution, I solved it. Now I'm going to make the triangle. So I'll do it over here so I can put that answer right underneath. So I draw my right triangle. Now, what I love about having sine is easy, right? So katoa. Opposite hypotenuse. So the opposite side, which is all the way over here, is x. The hypotenuse is 6. And remember what I've said again and again and again. The missing side must be this. So you don't have to use the Pythagorean theorem on it. You take whatever radical was in the original question and you just throw it down there. Right? So remember, we had op, adj, and hyp. That's convenient. Now, I want cotan. So the natural thing to do is say, well, I don't know the sides, right? You know the sides that go with sine, cosine, and tangent. That's why you do that stupid SOHCAHTOA thing. Sine was opposite of hypotenuse. I just use it. Cosine was adjacent to hypotenuse, and tangent was opposite adjacent. So if tangent is opposite over adjacent, that means that the cotangent is going to be the adjacent over the opposite. Now, on a personal level, I would rather just find tangent and flip that over. So, like, I would do tangent. I would say tangent is opposite over adjacent, right? Opposite over adjacent. And then I would just flip that over and get cotangent. And I do that. I don't like to play games with adjacent opposite because I'm not used to doing that. I'm used to doing opposite adjacent, and then I just flip it over. It's the same damn thing. So whatever you want to do, okay? So it's going to be the opposite of opposite adjacent, right? So you do adjacent over opposite. So he'll be on top, and the opposite side will be on the bottom, right? That's what I'm looking for. Adjacent, opposite. I mean, if you actually write them there, like I did, you're not going to do this part wrong. Now, again, I want to make it look pretty. So I'm going to take the negative and attach it to the top guy. It doesn't matter. You can leave it all the way in the front if it makes you happy. But I am going to take the 36 and move it down with the X. And I'm not going to forget my plus C. At this point, these are so complicated. See, you can leave it there if you want. You could put it on the bottom if you want. It doesn't matter whether it's on the top, the bottom, or the front, wherever you feel comfortable putting the negative. But I like to make it look like that. I don't even think that I would deduct the point if you if you do the test that has 3 of these on it and you forget the plus C. I don't even care anymore. These integrals are so hard and complicated. Your brain is so melting out of your ear by the time you finish it. You forget the plus C. It's like, I got that answer. I am so 100% happy. Couldn't care less about this plus C, but it's supposed to be there, so try to remember. All right, so this one again, they're complicated problems, so you have to take your time. I'm gonna give you the substitutions. You're not gonna have to worry about that part, but you still even just me telling you these. I mean, I'm gonna tell you this. Like I'm gonna say that if you see that, then you do that. So I don't think it's unreasonable to give you that. You still have to do all this other work. You still have to, write the thing down, take the derivative. You still have to plug it in. You still have to simplify the radical. You still have to simplify the integral. You still have to integrate it. You still have to draw the right triangle and put the sides back where they were. I mean, it's still a lot of work. So, me giving you this is just, who cares? It's just trying to help you as much as I can. All right. So, overall in all the videos, I did a total of 5 of these. So, and hopefully combined with the notes and the lesson video, this is helpful. These, like I said, these are by far the most advanced and complicated technique, and they can get very nasty. You can get things at the end that are a lot more complicated to integrate. There, you could very well have done a problem and gotten like tangent to the third, secant to the third at the very end. And, this is not trivial. You can get some really complicated things at the end of these. So just practice them again and again and again.